Hi everyone and welcome to this fifth video of BIOB20. In this video we're going to start with a normal distribution. We can create a random sample from the normal distribution with the function rnorm. With n equals 5, I'm going to create a random sample with 5 elements. As you can see, the normal distribution is continuous. The numbers are not integers. To learn more about the normal distribution, we're going to plot the histogram. But instead of using 1,000 like I usually do, I will push it a little bit and go to 100,000. We get a distribution with a single peak, which is symmetric. But I would like it to be a little bit more smooth. So what I'm going to do is replot the histogram, but setting breaks equals 50 to make more subdivisions. When we do this, we obtain a characteristic smooth bell curve. The normal distribution is the bell curve. The Gaussian distribution, or the normal distribution, has got two parameters. The first is the mean, and I'm going to set it to 100 to see the kind of sample I get. You can see that the numbers are all close to 100. The second parameter is SD, for standard deviation, and I'm also going to set it to 100. This time the numbers are still centered on 0, but you can see that the variations are much bigger. One of the numbers is even lower than -200. Let's now demonstrate a very important property of the Gaussian, or the normal distribution. I can, for instance, set the mean to 10 and the standard deviation to 50, and I'm going to generate a random sample with these parameters. So I start by setting the random scene to 1, 2, 3 as usual. I then create a random sample by setting the parameter mean to the value I defined and SD as well, and I obtain a random sample with such values. Now I'm going to generate a second random sample in a different way. I reset the seed to 1, 2, 3, and I'm taking the standard normal distribution with the default parameters mean equals 0 and SD, standard deviation, equals 1. Now if I multiply the result of this operation by SD and I add mean, you can see that I obtain exactly the same numbers. This shows that the parameter SD is just the multiplication of a standard Gaussian variable, and that the mean is the addition of a constant. This is one of the most fundamental properties of the Gaussian distribution. Talking about standard deviation, we are now going to see the function SD for standard deviation. First, I create a random Gaussian variable to have something to work with. If I compute the function SD on the sample x, I get a single number. That number represents the amount of variability between the numbers of the sample. If the numbers are very close to each other, the standard deviation is close to 0, and if the numbers are far away from each other, then the standard deviation is high. The standard deviation is linked to another function which is known as the variance, var, and the standard deviation is the square root of the variance. And this is all we're going to say about the variance and its relationship with the standard deviation. One of the most important properties of the standard deviation is that if I multiply the numbers in the sample by a number, like 100 for instance, then the standard deviation is also multiplied by 100. In other words, the standard deviation scales linearly with the sample. Now if we add a number to the sample, like 100 for instance, we can see that the standard deviation does not change at all. This is because the numbers now are equally close to each other or far away from each other as they were before. So adding a constant does not change at all the value of the standard deviation. Next, we're going to speak about functions. OR has many functions, and we can create even more. We start by getting something to work with, another random sample from the Gaussian distribution, and we can see that the function span in R does not exist. The span is the difference between the highest and the lowest value. One way to compute the span is to compute max of x minus min of x. But we can do a little bit better by creating the function span. The syntax to do this is to define the symbol as usual, the same way as we define a variable, except that we assign to it the keyword function. Function is really the most important part. And between round brackets, we put the parameters, x in this case. Then we put between curly braces the content of the function. There we can put the definition max of x minus min of x. X is not the sample that I've defined before. It is the value of the parameter that I've defined in the function. When I call span of x, I get the same result as before. If I create another random sample, which I call y, I can then compute the span with span of y. And actually, I don't even need to call the variable anything. I can plug directly in the parameters of the function the random sample that I generate on the fly. It's going to compute the span on that particular input. Functions are quite handy because they allow us to make shortcuts, but they can do more than this, as we're going to show in the tutorial. Next, we're going to see another way of using the brackets to select the elements of a vector. Again, we generate a random sample so that we have something to work with, and again, it's a normal random sample. We already know that we can select the first element by putting 1 inside the square bracket. What is interesting is that I can also put negative numbers inside the brackets. If I use -1, I get the whole sample except the first item. As usual in R, it does not only work with numbers, but also with vectors. Between the square brackets, I can put a vector of negative numbers. For instance, if I remove the first two, I get the last 3 elements. But we are not allowed to combine positive and negative integers. If you do that, you get an error in red with a message that only zeros can be combined with negative subscripts. It is also important to mention that R is quite different from other programming languages with this syntax. In summary, in R, you can use negative integers if you want to drop elements from a vector. Finally, we're going to speak about an important feature of R, which is known as the recycling rule. Let us first create some variable to have something to work with, and because I want to have integers, I'm going to use the Poisson distribution. And I'm also defining another variable which has the same length. The two variables x and y have got length 2. If I now want to compute x plus y, I get the element-wise sum. The first element of x is added with the first element of y, and then the second element of x is added with the second element of y, etc. Now what happens if I have two vectors of different length? Let's say that y has length 4 now. Surprisingly, x plus y works just fine. As usual, R adds the first element of x with the first element of y, then the second element of x with the second element of y, and x is finished. So what it does is that it recycles x to use it another time. So it's going to add the first element of x with the third element of y, and the second element of x with the fourth element of y. This is done automatically and without warning. So you have to know that this is what R does all the time. What happens when the lengths of the vectors are not really compatible? For instance, I can set the length of y to 5, so let's see what happens. Now when I do x plus y, it still works, but I get a warning in red. The problem is that 5 is not a multiple of 2. But the rule does not change. OR has recycled x as many times as needed, so for the fifth element of y, the way it does it is that it adds the first element of x with the fifth element of y, and the sum is finished. There is no sixth element. So the recycling rule makes many operations really easy in R, but it's important to understand that it's operating all the time, and that sometimes it's not going to have the effect that you want. Finally, I would like to talk about a way that you can prepare nice documents using RStudio. I'm going to demonstrate the basic properties of R Markdown. To create an R Markdown document, open RStudio and go to the top left corner. Choose the menu R Markdown. This may take some time, as shown by the spinning wheel here. The first time you do this, you may need to install extra packages. If this is the case, click Yes. The install process then starts, and it can take a few minutes. As soon as this is finished, you're asked to fill in the basic information about the document. I'm using the extension .RMD that stands for R Markdown. I like my default output to be PDF, but I can choose HTML or Word. You then get a new panel with a pre-filled document. There is a header with the information that you have just filled, but you can replace it at any moment. You can see some blocks of R code which follow that particular syntax here. The information in curly braces specifies that this is R code, gives a name for the block, and gives some option for the inclusion of the display. There is also a green play button that you can press if you want to run the whole block in the console below. When you do this, the lines are moved and executed. There are also blocks of text in a language that's called Markdown. This is a pun on markup, which HTML stands for. Markdown is used on many platforms like Wikipedia or Stack Overflow. It allows you to format the text a little bit. For instance, these two stars here say that the text has to be in bold. The first block of R code did not output anything, but the second has an output. And as you can see, the output of this command is included in the document. And when the output of the particular command is a plot, it is also included in the document. In that case, a PDF of the figure is simply included in the flow of the document. At that stage, you just need to replace the pre-filled commands with your own and the pre-filled text with the one that you like, and also add the blocks of R code that you need. You should of course save your document regularly. If needed, give the right to RStudio to modify your file system. To create a nice looking output of the document, go to the option Knit above. You can choose to create an HTML, PDF or Word document. I'm going to go for a PDF. The rendering takes a few moments. When the document is ready, you can visualize it. You can see that the title and the date have been filled in, and the outputs of the commands are present in the document. Also note that the blocks with equals false do not show the commands that were used to produce them. This allows you to include figures without having to show the lengthy commands to create them. R Markdown has become the standard way of sharing documents when they're prepared with R. It is a very simple way to keep your code tidy and share it with others. That's all I wanted to share with you today. Good luck with the quiz, and see you at the lecture.